Thank you for attending this morning's webinar on data-driven yield prediction. My name is Chris Kennard, and I will be moderating the session today.
Apologies, everyone. I was, of course, on mute. Classic webinar move. But yeah, my name is Nicole Osterwald. I'm a territory sales agronomist with Farmers Edge. I've been with the company just since April, but full-time in the industry for a little over 8 years now. So today I'm going to discuss data-driven yield prediction. Specifically, we're going to talk about our data collection process, why this tool is important, and how it can be of benefit to you. So to start off, I wanted to provide a brief overview of the Farmers Edge platform. So Farmers Edge leverages a unique digital infrastructure that combines 4 key components. So the first is that on-farm hardware for field-centric data collection. The second is software to drive insights that support informed decision-making. Third, we have our agronomy group for crop planning and optimized use of crop inputs. And then fourth is really our key thing here, our boots on the ground support to validate our models, ensure data accuracy, and provide overall a great customer support and experience. So overall, the combination of these factors in our system is really built to provide the best possible experience for our customers by combining these 4 key things. So again, machine learning yield prediction is what we're here to talk about. So what is it and how does it work? So spatial information is taken from high resolution, high frequency satellite imagery that can place NDVI crop health values on fields quickly and precisely. So what this allows us to do is look for erroneous values or regional issues with crops that may lead to some impacts on our yield potential. These spatial trends help identify whether areas are on track or maybe there's environmental pressures or other issues that have impacted that crop's yield potential. So really this tool provides yield prediction values for your operation as the season progresses. So as you can see in the picture here, numerous fields across the farm, and we can kind of see with that scale what the yield potential values are at, and maybe certain areas of the farm that might have a higher yield potential than others. This feature is currently available for our canola, lentil, wheat, corn, and soybean crops. We also have yield prediction values for other crops, but they use the DSAT system and our moisture manager program. But today we're just going to be focusing on our machine learning yield prediction aspect of it. So again, we have 3 of them, but today just focusing on the machine learning yield prediction tool. So how does the yield prediction model system work? So here we have an overview of how the information and data is gathered and used to provide you with a final yield prediction for your crops. Really, the main goal of this system is to get the right data and use it in a way that provides value. So first and foremost, what we do is we start with a large variety of various data sources. So this includes things like soil fertility and texture results, satellite imagery, weather data, and regional data. We then take all this data and extract it and load it into source data sets, or basically a data science warehouse. So essentially, this step involves taking all of that raw data and making it valuable on a local level. The next step in the process is called featurization and transformation, where we take the raw data and turn it into something useful. So for example, using weather data to calculate growing degree days. These features that we create can lead to positive or negative correlations. So for example, with canola, we might see a negative correlation when hot days are exceeded for too long in a certain growing degree day window. So, kind of eluding a feature, creating that to include or equal to heat blast, right? So that's kind of the idea there. So now that that data has features and using previous year's data, verified data, what we do is we build training and prediction data sets that make the yield predictions. So for example, we know from previous years that NDVI imagery that says this at this point in the growing season points us on a trajectory towards this yield value. However, just because the data is available doesn't mean we use it. So the model does decide what it feels is most valuable to use. So feature selection is important because extra features which have no bearing on the target add complexity that we don't need, really basically makes the model more complex without any benefit. So it's important to choose the features that are going to help us predict that yield. Finally, the system creates the predictions, and then you're provided with a valuable data set of yield predictions for your operation. So yeah, kind of a complicated thing there, but to give a few analogies, so let's say we're baking a cake. So the data sources would be the store, and the source data sets would be our fridge at home. So we don't always want to have to be running to town for ingredients. So basically what we're doing there is we bring them home to the data science warehouse, which, AKA our kitchen. So really, again, making that product more local. And then the featureization is transforming that data into something useful. So an easy way I like to think of this is, wheat off the back of the combine versus flour for a cake. We're taking something and putting it into a form we can actually use. So that was a really high level overview of how the system works. This is not at all key in understanding how to use the tool, but I did want to provide a bit of background on how the data and yield prediction values we provide are created. So what are some things that can impact the accuracy of the system? So there's a few things listed here. The first one is just the verified data. So this is used in training the model and is important when determining which factors contribute to yield. Incomplete data sets lead to less accurate predictions because this info is really key for training the model. So again, making sure that we have a good set of verified yield data, verified data from the previous growing season is key to making the next season's predictions that much more accurate. The second is the point of time in the growing season. So we collect more data as the season progresses. So early in the season, there's still lots of unknowns. We're just beginning the growing season, so we don't have as much data to put into that model, and the prediction is less accurate. As we move towards the end of the season, we get to fill in more of those unknowns with things like weather, NDVI, etc., and then our prediction becomes a lot more accurate as the season progresses. And then finally, one thing that can impact the accuracy of the system is when things go outside the norm. In some cases, we don't have that previous data to learn from. So, for example, if we were going to seed canola in Saskatchewan on July 10th, if this were to happen, we would need to understand how this impacts yield in order to train the system. So the model uses training with known data and tries to apply it to unknown. So again, we're always trying to train that system and use previous years to kind of predict that, but when things go outside the norm, it makes it a bit more challenging. So one way to think about this, we're on this trajectory based on these factors being this way and leading us to this target, say that's what happened in the past, and we kind of roughly base that off the same thing. As things happen that are new and impact this, we first need to train the system to consider these new features. So one kind of, I'm going to throw another analogy out there. One way to think of this is humans' understanding of drink containers, for example. So we know what a sippy cup is or how a coffee cup works, but let's say they come out with a new type of drinking container, for example. So, a few years back when they brought out the backpacks with the water container and the attached line to drink out of. So as humans, we had to train ourselves to understand that this qualified as a drinking container as well and how it would be used, because it was out of the norm for what we would have previously considered to be a drinking container. So now all of a sudden we have to train ourselves to think, okay, yeah, this also fits the category of a drinking container, and this is how it's used. Even with the drinking containers, right, we understand that usually we're not going to give a coffee cup to a toddler, we're going to use a sippy cup instead. So again, just understanding how to define these things and how they impact the end result. So what causes change in yield predictions? There's two things that usually cause changes to yield predictions. There's in-season changes, and then there's retraining that crop model. So when we're doing our predictions in season, there's lots of things that can impact how that yield potential is going. So, the addition of new imagery, new data, new weather, all of those things will change the prediction as the season progresses, because it's taking in that data and that information to adjust that yield prediction. And then we're retraining the models every day as well. So anytime that, there is a change in the training data, or we make a change to the model, in general, that's going to make a change to those yield predictions as well. So as the season progresses, you will see that yield prediction does change, which makes sense because I think that means that we know it's working, right? If it stayed the same, then we obviously wouldn't be using that data that we're collecting appropriately. So how do you start having yield predictions created for your farm? So Farmer's Edge and the FarmCommand system requires a grower to do two things, really quite simple. So the first is create crop plans, and the second is to start and complete jobs as you're doing applications on your farm. And then the rest honestly just happens. So we make the insights available for you. And then of course our team of agronomists and techs and everyone at Farmer's Edge is here to support you and help you and answer any questions you might have on that as well. Why should you do those two things? Why bother creating a crop plan and jobs? So the data we collect from this process leads to insights which help us in our actions or decisions on the farm. And that's really why we're collecting data. Just because we can collect data doesn't mean we should, right? We want to do something useful with it. So when we collect the weather data, the satellite imagery, the soil data, and the regional yield data, that helps us create yield prediction values, right? And then once we have those yield prediction values, that helps us when planning harvest logistics, grain marketing and inventory, as well as in-season and pre-harvest application decisions. So again, we want to collect this data because we are currently, making something very useful with it. And that's really helping us with those, planned applications and decisions, management decisions that we have to make daily on the farm. Again, taking that data and turning it into something useful to help you. So again, yield prediction, what's the value? And the main thing that we want to think of with this tool is really yield prediction helps you plan ahead. So, talking about harvest and post-harvest logistics management, for example. So, do you need additional harvest help? What's your combine grain cart trucking needs going to be like? Maybe you can do it with one semi and going from the field to the yard, or maybe you need 2 or 3. So depending on what the harvest looks like, all those demands for on-farm help and the logistics at harvest definitely change, and this can help you plan that a little bit better. When we're talking about grain marketing, so just understanding, the yield potential there for what you think you might be able to contract before harvest is over, really just helping you understand that, again, what we think we're going to actually have at the end of the season, because that's often a hard thing to understand and know. So this is again another tool to help you understand, okay, I have this much grain, I've already contracted this, for example, or I can contract this much more. Also key in calculating our break-even costs. So we understand, what we've put into that field so far for crop inputs. Understanding that yield potential really helps us in calculating our break-even costs as well. And then, grain storage and inventory planning. So based on this yield prediction model, do we need more storage on the farm? Is that something we want to get done before harvest comes? Which crops and which bin? We could compare our soybean versus canola yield potential on the farm, considering the difference in seed size on those. They obviously take up more or less space because of that. So we can again compare the yield potential of crops across the farm as well. Just help us determine, when we're planning to where we're planning to store everything on farm and which crop's going to go in which bin, and just understanding overall inventory management in that farmyard as well. Do we need grain bags? Those have become quite popular for that little bit of extra storage that you might need to keep in the field until you can sell your grain and bring it to the elevator. So again, is our grain bags something that we want to use or need based off of the yield prediction values that we're seeing as well? And then do we want to do on-farm storage, or do we need to do immediately off-farm delivery? So are we going right from the field to the elevator with that crop, or do we want to bring it and store it on farm because we have the room for it? And then the last thing here, just it helps us plan application decisions, right? So understand that yield potential during in-crop applications. So is that yield potential there for that fungicide application? Obviously, disease pressure and those things come into that decision as well. But again, this is another factor that can help you decide where you want to be with those crop inputs. Same with things like top dress applications. Is that yield potential there for that extra nitrogen application? Again, other factors come into that, such as crop stage and things like that. But again, just another tool to help you in those management decisions on your farm. Can also help determine the need for desiccation and pre-harvest applications. So again, going back to that harvest logistics, the timing, maybe we need to desiccate a crop that we normally wouldn't, just because, there is a high yield potential on the farm this year, and we want to be able to account for that. And just manage that timing at harvest a bit better as well. With a lot more straight cut varieties, a lot of the time, we're just letting that canola sit out there, but, maybe we need to do a desiccation application to help bring that crop in sooner, just so we can get harvesting it sooner as well, just because fortunately the year is looking like it's going to be one with, high yield potential, and we can take that factor into consideration. So again, what's in it for me? So the yield prediction model is another tool you can help use to plan. That's really the key thing that we want to take away here today. Is it's just another tool to help you with your management decisions on your farm. So, currently there are lots of unknowns on the farm, but this is some of the data that we can collect. And then this is something really that we can use to get a rough idea of what harvest and grain inventory are going to look like, to help us prepare accordingly. So again, it's really all about using this data to create insights that help you with your actions and on-farm decisions. So it's really a key planning tool, and something that we can look at throughout the growing season, understand how those yield predictions are possibly changing, what that looks like, and continuously changing our plans or planning accordingly with this helpful tool. So that's all I had for you today. If anyone has any questions, please feel free to put them in the chat. You can also email info@farmersedge.ca or call the number here as well for some more information, and we'd be happy to help.
Yeah, thanks, Nicole. I'm not seeing anything in the chat here so far. Oh, actually, looks like we have one. Yeah, and so it looks like there's maybe some questions, and if you do have questions, please feel free to type those into the box. If not, we can follow up afterwards. So I'll just give that a minute or so here. So one question here, during yield prediction, is the size taken into consideration? I'm not sure if that's referring to the field size. If so, we are taking into account a spatial boundary that would measure the size of that field, although not necessarily a particular value contributing to the yield potential, obviously contributing to the yield average within that field, but not necessarily the production potential. Awesome. Well, I'm not seeing anything else at this moment, so thank you very much, Nicole, for the presentation here today. And for those, we will follow up afterwards. So have a good day, and we'll talk to you again soon.